Hello and welcome to the Why Your Assortment Isn't Returning Maximum ROI webinar. This presentation is part of a series of webinars presented by 4R Systems. My name is Kevin Stadler and I'm the President and CEO of 4R Systems, and I'll be presenting in the second half of this session. This session will be recorded and will be available post-event on our website. And as a little note before we get started, all of the phone lines are currently muted and will remain muted throughout the presentation. We will be taking questions via the chat feature that you'll see on the right-hand side of your screen throughout the webinar, and the questions will be answered at the end of the session. We'll answer as many questions as possible as time allows. Today, our agenda starts off with the background on our approach, takes you through the methodology, and then we'll discuss learnings and a brief view on the solution that employs the different techniques. And now I'd like to introduce our main presenter, Dr. Marshall Fisher from the Wharton School and a founder of 4R, to talk about attribute-based assortment optimization.
Okay, thank you, Kevin. Let me give a little background on what motivated us at 4R to create an assortment optimization product. A few years ago, one of the retailers that was using our inventory product asked us for advice on effort they were engaged in to improve their assortment optimization, assortment planning process. They had bought one of the assortment products that was available, and they were investigating other products, and they were struggling to make this work for them. And when we looked at the capabilities of the product they had and the others that they were considering, it was easy to see why they were struggling, because these products didn't answer the obvious questions that any retailer would have about assortment optimization. If I add this product to the assortment, what do I predict it will sell? And how much of those sales are going to be incremental and how much are cannibalizing things that are already in the assortment? Or the converse of that, here's a product that's not selling very well. If I delete it from the assortment, how much of those sales am I going to lose and how much will transfer to other products? This retailer also essentially offered the same assortment in all their stores, and they were thinking that they ought to adjust the assortment based on differences in preferences of their customers around their 3,000 odd stores. And so they were clustering their stores in different ways and trying to adjust the assortment. But the obvious question was, how do you cluster your stores? How do you change the assortment based on store cluster? And then if I do all of that, what's going to be my increase in revenue? Couldn't get an answer to those questions. When we looked at analyst reports, and you're seeing one from AMR, they were saying the same thing, that this particular report asked retailers, what do you want in assortment optimization tools? That's the top bar, the more lightly colored. And then what percentage of what you want are you getting? The biggest gap was, what did they want? They wanted predictions. They wanted to know what would happen to revenue if I make some change to my assortment. And that was the thing they were getting less of. So that was the biggest gap. Barry Schwartz, a professor at Swarthmore College. So it's a bit of a guessing game for a retailer to manage their assortments. What's the obvious human response is to overcorrect on assortment breadth, add more and more products to the assortment to make sure you're not missing any sales. Well, interestingly enough, Barry Schwartz has authored this book, The Paradox of Choice, professor at Swarthmore College, found that as you grow the breadth of your assortment more and more, you reach a saturation point and you go beyond that. You're not adding revenue, you're simply confusing the customer. That has led a lot of retailers to do what they call assortment rationalization, which really means cutting SKUs out of your assortment. Here's a report by Gartner that shows that those tools don't work very well. Lots of retailers have had bad experiences. Probably the best known one is Walmart's Project Impact, based on a number of sources of information, including customer surveys, who said their customers said their stores were too cluttered. So Walmart substantially cut products from their assortment about 15% and saw a huge dip in revenue that forced them to put most of that back. So that didn't work, okay? I joined with an academic colleague, Ramnath Vaidyanathan, who at the time was at McGill, and launched a project to, research project to try to kind of fill this void. And you know, what is the void? If you think about setting inventory levels, prices, there's been a lot of great analytic tools developed, including ones offered by 4R Systems, to help you analyze data and improve the way you set inventory levels pricing. That hasn't happened in assortment optimization. It's still the last bastion of the merchant prince, mostly based on human judgment. We recruited several retailers to work with us, including some of the retailers that were using 4R's inventory product. We met frequently with them. We sat through their current assortment planning processes and developed a set of ideas intended to correct the void we saw in the current products that would predict demand for a new product if you added it to the assortment, would predict how much that cannibalized existing sales, and would also let you intelligently vary your assortment by store or clusters of stores. Results have been published in an HBR article, which is shown here, and a more technical article in the Scientific Journal of Management Science. Okay? What was the essence of this approach? First thing is to identify attributes of your products. Typically, we find 3, 4, 5 attributes work well. Grocery, brand, flavor, package size often work. Apparel, footwear would be style, color, various aspects of the silhouette. With jewelry, you could think of the material. Is it gold or silver? The gemstone, is it diamond, something else, or maybe none? And price point with jewelry. And interestingly enough, what motivated us to think about attributes is that's what the best buyers at the retailers were doing. They thought about their products conceptually in terms of attribute. We sell more apparel. We sell more black in Manhattan than in our Madison, Wisconsin store, for example. So what we tried to do is take that solid conceptual framework that we're using and turbocharge it with analytics and data. Okay, so that's step one. Think about attributes. Step two, we developed a way you could use your sales history of products you're currently selling to predict the demand for different attribute levels. Okay, how many customers want? If you think about price point, good, better, best, how many want the good product, how many want better, how many want best, and how does that vary by store? Number three, once you know the demand for attributes, you can now forecast the demand for a new SKU added to the assortment, which consists of a combination of attributes that you're not currently offering. So you offer all the attributes, but not in a particular combination. Add this product at the top price point, for example. Will that sell better? We can also estimate if a customer doesn't get what they want, either because it's not in the assortment or you deleted it, will they substitute? And then when you know all of that, you can choose assortments, localized by store, if you want to maximize revenue or gross margin or unit sales, and constrained by potentially by SKU count, or by space in the store, or by inventory investment. Okay, that's the concept. This next slide shows attributes that we use for a couple of studies. Snack cakes, we use brand, flavor, size. For beer, we use the flavor, package size, package material, country of origin. And then this next slide, I need to take a couple minutes to delve into some of the technicalities, but I think it will show you the essence of the method. This is a study we did with a tire retailer. And working with them, we identified two attributes of tires. One is size and one is price value point. Size is a technical parameter, as shown there. The last number, for example, is the diameter of the tire, which could be 14 or 15 inches or 16. R stands for radial. But you feed in, you can find these websites easily. You feed in the make and model of your car, and that will tell you exactly, here's the size I have to use. So there's no substitution across that parameter. The other attribute is price value, and they had 6 price value points. So what the slide shows is the sales at one store over a 6-month history period, and where there's a blank, and that's an option that was not offered in the assortment. Okay, we had about 100 sizes. They don't all fit on the slide, so this is an excerpt of that data. Okay, and what I want to do, walking you through some of the computations we did with this slide, is that there's a ton of information buried in your sales data that can be tremendously useful in improving the assortment that you're offering if you know how to mine that data. So the question this retailer faced was, what should I drop from the assortment? What should I add? And how much should I vary my assortment by store? To answer those questions, we created a demand model, and the key parameters in the demand model were a percentage share by the 6 different price value points. Okay, so 100 customers walk into your store. They know their size. They all have the same size. How many would want the lowest price tire? How many would want the next best, and so forth? Okay, and then we estimated those parameters so that the predictions from our demand model of things you were already selling, it's called backcasting, best matched the actual sales you'd observed. Okay, and those best fit parameters are shown at the bottom. Okay, so what does that say? If 100 customers walked into your store, in this particular store, 70 of them wanted the lowest price point. If you showed them all 6 options and said, take your pick, 70 would have chosen that lowest price point. Notice that that is dramatically different from the 11% sales that you're actually seeing, right? So how could it be that our demand model says 70 customers would like the cheapest tire, and you're only selling 11%? Right? Well, you look in that last column there, and I think you can see the answer is that they didn't offer the lowest price tire in very many sizes. Okay, so if you don't offer it, you're not going to sell it, and that's what depressed sales down to 11%. And their model, not surprisingly, was we'll offer a few cheap tires to get the customer in the door, and then we'll upsell them to the next highest price tire. Okay, if you look at where the customer had a choice of fair versus good, and there are 3 options there that are highlighted in the red square box. I mean, the data screams that price matters to these customers. You could also see it at the chain level. I think the lowest price tire outsold the next one like 20 to 1. Okay, tremendous demand for that lowest price tire. Okay, that's point 1. Now, second point. Does their model work? Does their model of upselling the customer work? It could be a smart model if people are willing to substitute, to trade up. Okay, how do you measure that? Well, we estimated that parameter to be 60%. In this store, 60% of the people, so of the 70% that wanted the cheapest tire, you could convince 60% of them to trade up. How do we know that? Well, look at those instances of good versus better, where you don't offer the cheapest tire. Good outsells better, something like 3 to 1, right? Where that cheapest tire fair is offered, the ratio good to better is about 1 to 1. Okay, so why would good sell so much better when you don't offer the cheapest tire? Well, the obvious answer is that some of those sales of the good tire are people who wanted the lowest price tire but traded up. Okay? And so the point being, there's information in your sales data that lets you measure how customer demand transfers if you don't give them what they ideally want. Okay? Now, it turns out that economically, that this retailer strategy did not make good economic sense. Because even if 60% trade up, you're walking 40% of 70% of your demand. That's a huge amount of lost sales. That lost sales was vastly more expensive to them than the fact that they were selling at a slightly higher price by getting some people to trade up. With this information, we could recommend what to add and drop in each and every store. We could show them how to cluster their stores. Their goal was to maximize revenue. We did that. We deployed our recommendations, or they deployed our recommendations, and the result was a 5.8% increase in revenue. So that's one example of one study. And I think the key takeaway I'd like to leave you with on this slide is you already have a ton of useful information in your sales data that could help you improve your assortments if you simply know how to mine it. And 4R has developed a product that will let you do that and then use that information to enhance your assortment offerings. Here are some of the things we've seen in studies. First of all, the revenue improvement. Everybody wants dramatic, huge improvements, single digits, 3 to 6%. Might seem small, but that's a huge number. If you think about these days, most retailers are eking out, at best, 1 or 2% comparable store sales growth. So this is 3 to 6% just from one initiative. What we saw in the previous slide is there's a self-fulfilling pitfall that retailers can fall in. We don't think our customers want cheap tires, so we're not going to offer it. You look at the sales data, it's only 11% of sales. Yeah, we were right. So what you think you know what your customers want. That guides the assortment you offer, but what you offer is what you sell, so you look at the sales data in a simplistic way, and you feel like you're doing a good job. This tool lets you uncover true customer demand in the sales data. We can measure substitution rates. We found that they vary greatly by store and by product and have to be taken into account. We can localize the assortments. One interesting thing that this tire retailer found out is that the lowest price point store was in Puerto Rico. People seem not surprised by that fact, but guess where their highest price point store was? Puerto Rico also. So there's a lot of wealthy people in Puerto Rico. They got to buy tires somewhere. So simply geographically localizing your assortment doesn't work. You got to look at actual demand parameterizations. And then we married that with demographic data to help understand what's going on. So that's a little bit of insight into why we developed the tool, to fill a void in what's out there, and how it works and some of the benefits that it can provide.
Thanks, Marshall. Let me give you a little bit of a backdrop. Now, once you evaluate this technique, we're talking about a way of deaggregating demand down to its attribute level inside of an estimation system, and it has a lot of both key differentiators as well as benefits. I mean, one of the things as you look at this is that this model, the way that it's built and the way that the underlying parameters within it is built on a data model that considers true demand, not just sales. So a couple of things are factors here. Because we're actually marrying up a base model that we have developed here at 4R that looks at perpetual inventory, when they're out of sales situations, and then models true demand. Then on top of it, as Marshall had pointed out, inside of the data, there are items not being offered. It provides you with a very powerful way to use attribute demand modeling for estimation and in addition, new item contribution on items that potentially are not even in the assortment today, which helps to correct for the situation that Marshall had talked about, which is many times in assortment there's a self-fulfilling prophecy, which is what you have is what's going to sell. Absolutely true. So you've got to go the next level down in order to underlying find what the demand levels are. It also has the ability to select the level of localization. I mean, there's two things going on here. Early on, Marshall had talked about the fact that typically there is a lot of proliferation in assortment. The two factors are localization and proliferation that you need to understand at retail, which one provides you, quote unquote, the bigger bang for the dollar, and understanding what it is. And this technique allows you to do localization and align your technique. The cost benefit of increasing the assortments here is also important. Many times you can look at it and say, here's my existing assortment, here's a proposed assortment, look at proposed demand, and determine whether or not it makes sense for you to actually do that change. Demand transference effects are inside of this so that you could look at redundant SKU combinations in terms of redundant attributes that are being offered. As a way of working, we use this model to leverage existing data feeds so that you don't have to recreate everything that you're doing. We use existing pieces that are inside of retail merchandising, space, supply chain systems, and we model it and put it into the assortment planning system. Through it, we also can provide output. Beauty of the approach is that ultimately what happens is there's a look at the existing assortment and the new proposed assortment to provide you with an add, delete, and retain by item / SKU to allow you to look at what would be the changes, one assortment to the next, in what you're currently doing. And it also provides you with very rich optimization outputs, especially when you get to inventory cost implications and what it's going to take to actually change the assortment. A few other things that we'd like to talk about here is that the system and the way that we implemented this automatically includes in it a test and learn capability. We're tracking inside changes, fidelity to changes. In other words, you may have proposed an existing assortment to be changed to a new one, but not often can you do it just on day one. The fidelity changes over time. Some people take a while before they can get to 100% fidelity to what the change was. And there was also a study that we did a few years ago that indicated once you even did a quote-unquote change of the assortment, it did not always hold up at retail. Sometimes the assortment changed over time. So we can provide you with a fidelity measure of how close it is to the optimal assortment. Test and control selection inside of it. And as we talked about before, it has the ability to look at and provide for all stores that operational feed. In addition, one of the things that I think is key relative to traditional thought, category management thought in terms of line reviews and how often you change an assortment, this capability now provides you with an ongoing ability to monitor and trigger changes based upon how big the delta is of the potential. In other words, you might have certain categories or certain lines that you only want to do once a year. You might have others that could benefit a lot from reassorting on demand at different times. You also could put in a schedule if you wanted it to. But the key here is that you want to avoid costly work operationally to reassort when there's little to no benefit. Solution itself works through a kind of a five-step workflow. You're getting on this screen a little bit of the snapshots in the upper section to show you roughly what it looks like from a web perspective. This is a software as a service solution so that you actually access this through a web browser. And step one, you model the current environment, and that allows us to build those models underneath. We run our algorithm, and they provide you with that demand estimation. We then optimize based on, now that we've got those models built, determine the levels of either localization, proliferation, what's the right strategy that can be done by retail personnel or in addition with 4R personnel helping. Once that's determined and there is a benefit which has been projected, you can pilot, actually do a rollout. System is self-feeding, and so you can look and see how it's doing versus test and control, and look at the key metrics during the pilot and rollout. Typically, you have to allow a certain burn-in period of putting a new assortment out there into retail before the consumer notices. So there is a burn-in period, and then you actually see what the results are. And if the results then on your test of an optimized assortment are what you wanted, you then can deploy by rolling that out through the changes to all stores. And then similarly, you can monitor that performance inside of this tool on an ongoing basis. So as you can see, it provides a complete cycle from start to finish and loop back around to start again to decide when is the next time that you need to do reassortment. So we find this 5-step workflow to be very close approximation to how most retailers think and work. The value creation, if you looked at it and you said, how could I actually go about doing something like this, is the following. We first work with the retail organization to do data collection and verification. Obviously, product attributes are exceptionally important here. And we need to look at the product attributes and work with the retail organization to both normalize attributes and find out, as Marshall said, what are the top 2 or 3 attributes that are most important by category. Second is to do a sample category analysis to look at, what is the demand model, how could it actually improve things, and work through kind of a one-off category analysis. Last, obviously, is then to validate those benefits through a pilot. Some people propose to do this. Some people, because there is such an operational improvement with the ability to do attribute-based optimization, that they go directly to day in, day out usage of the solution. So with that, I hopefully gives you a bit of an overview of both methodology as well as how a solution would work, and then a little bit more on how you might be able to use the solution. So with that, we will open it up to questions. So our first question is, as a vertically integrated retailer, can I use this to help design new products? Marshall, do you want to answer that one?
Yeah, yes, of course you can. More broadly, if we recommend adding an assortment to a product to the assortment, where's that product going to come from? There are 3 levels. The quickest to act on is we found that there's quite a bit of revenue enhancement to be gained simply by how you allocate your current set of product offerings across stores. So you've got a product you're selling in some stores, but not all stores. We might identify opportunities where adding that product to additional stores could drive revenue. So that's the easy one. Product sitting right there in your distribution center. The second level of speed of action are products that are being sold in the marketplace, branded products sold by by vendors that maybe your competitors offering, but you're not. We see that as an attractive opportunity. That can be done pretty quickly also. And then if you're a vertically integrated retailer, it may take a little longer, but this tool will identify products that you need to develop, perhaps in conjunction with one of your suppliers, that could be added to the assortment. So any vertically integrated retailer is always thinking about product development opportunities. They're constantly developing new products. Some succeed, some don't. This tool will give you recommendations that have a better chance of succeeding.
Thank you. We have a second question. This question is, how could something like this integrate into a space management system? The answer to your question is, if you looked at, in different retailers have different levels of space management capability that they use. Some go as specific as developing planograms in different sizes, 4 foot, 8 foot, 12 foot, etc., for different geographies or clusters. The beauty of this approach is that the output can actually be generated either store-specific or on a cluster basis, and the output on an SKU basis has an add, delete, retain. So you can take an existing planogram and use the automation capability inside of it. There are a number of these on the market today that have automation capability built on top of space management. Simply what's happening is on a add, it actually then adds that SKU into that planogram. It then uses the D, which is delete for the SKU, removes those, and then R obviously is retains the ones that are there, and can be used based upon a way to automate that to then force what is the correct amount out there. So this can be used a variety of different ways with a space management system. We have a next question, which is our current product attribution is not very clean. What is the level of effort typically required to get this data to a place where it enables the appropriate value creation in this process? I'd answer that the following way. Now obviously, most retailers have a variety of, let's just say, data sources, and sometimes the product attributions are not great. What we're looking for in most cases is to be able to normalize the information and then have the key attributes. So it does not always take a large number of attributes. It just takes the key ones that the consumer is looking for, and then the second part is normalizing it. I will give an example of, we deal with one retail organization where the example would be chocolate is actually spelled any one of about 8 different ways, but it's all the same amount of, or it's actually all the same product, and the attribute is always the same. It's a flavor, and the flavor is chocolate, even though it's 8 different ways. So what we do is we actually normalize that data down as part of our implementation process to do that. So anyway, the best way to look at it is we get fed in the attributes. We look to see if they're actually the key ones. If they're not, we can augment those pieces of information. If it requires normalization, then we work with the retail organization to normalize it. But it's typically one of those two. Find out what the key attributes are, number one. Number two, normalize the key attributes.
And maybe just to add to that, in the process you described, step one, demand modeling, one of the metrics we get out of that is a measure of accuracy, likely accuracy of the forecast. And the tool lets you experiment with different attributes and see how they impact accuracy. So the tool actually will help you discover what are the key attributes that are predictive of customer behavior.
We have a next question, and the question is, what is the time that this takes to implement? It's somewhat variable, quite frankly, and the reason why it's somewhat variable is depending upon the steps that the retail organization wants to work through. Step one always is we have a standard data interface specification, and that data interface specification, once we get that, we load it into these models to run it against it. We then work with the retail organization, typically to do a category where the retailer can do it. Then after we get to that, we go out and test. The test or the pilot usually has a duration which has direct correlation to the selling pattern of the items in the category. What I mean by that is, if it is a relatively fast-moving category, you can test it in a short period of time. If it's a relatively slower-moving product category, it takes a little bit longer to do that. From start to finish, it can be done as little as a couple of months to load the data in, do the optimization, actually do the test. In a faster category, in a slower category, it would take a little bit longer than that.
So one specific example, which I'm well aware of because I've been working on it, we got data May 1st in place, and I think we delivered recommendations July 1,
yeah.
Which the retailer then acted on, and the pilot has already started.
So the next question is, during the demo, it sounded like the retailer needs to have users engage with a cloud-based software. What skills are required to leverage the modeling and the analytic tools? So the answer to the question is the tool itself does all of the work for the optimizations, both the estimation as well as the output itself in terms of what are the add, deletes, retains as it goes through. There is one step, which is the question of which are the key attributes that does require looking at from both a retail side or an analytics side to determine which are those key attributes, and that's one of the main factors. Our findings would be the following. It can be done by a retailer with knowledge of their category and knowledge of their attributes, and there is some training that, a little bit of training which is needed to understand how high or how good the correlation is with those items. So it does not require a lot of analytic capability, but we would argue some is good. How we normally implement is if the retail organization initially says we don't have the right set of skill sets, we'll actually augment that with personnel on the 4R side to work through the projects back and forth. However, once the first project is done, typically the retail organization can do everything that needs to be done in that cloud-based environment once they've used the screens or seen them once being worked through by some other person. So it's one of two answers. Either the organization can do it from day one, or they do a bit of a ride-along with one of our people, and then they do it long-term. I believe we're out of time, but we wanted to thank everybody for attending this session. Appreciate your questions. If you have more questions, please submit them to us. We'd be glad to answer them. And if you would like to have other folks in your organization review this presentation, it will be available on the 4R website, and we will have that up, I believe, in the next day or so that you can look at it. Thank you very much.